All right, solving absolute value equations is easy if you're good at what we just did, which is solving regular equations. First, though, a couple reminders that lead into this. What's the absolute value of negative 13? 13. What's the absolute value of positive 13? 13. What this means is that there are two numbers that when I take their absolute value, I get 13. Okay? And the reason that's important is when I solve absolute value equations like this one, the absolute value of x plus 5 equals 17, I have to remember that there are two numbers that when I take their absolute value, I get 17, which means there are two answers. All right? So setting this up is easy. I set it up, I set the x plus 5 equal to 17, and we're going to solve that. But I also have to set up a second equation. I have to set it up as x plus 5 equals negative 17, because you just told me that there are two numbers that when I take their absolute value, I get 17. One of them 17, the other one's negative 17. So we just solve both these equations and we get two answers. All right? This one's pretty easy. Subtract 5, x equals 12 is one of the answers. I solve the other one. Subtract 5, x equals negative 22 is the other answer. And all you have to do is just mentally check these, and you see that they make sense. If I put a 12 in here, isn't 12 plus 5 17? And the absolute value of 17, 17. What if I put in negative 22? Well, negative 22 plus 5 is negative 17, and the absolute value of negative 17 is 17. So both of these answers check out. So if I'm solving an absolute value equation, all I have to do is set up both equations and solve them both. All right, all the skills that we just learned in the last unit still work. Let's do another one. Help you feel a little bit more comfortable. Let's say that I have the absolute value of 2/3 a minus 4 equals 12. Well, what I just told you is that we're going to have two answers. So we need to set up two equations. I set it up the way it is. 2/3 a minus 4 equals 12. And then I also have to set it up as 2/3 a minus 4 equals negative 12. Because there's two numbers that when I take their absolute value, I get 12. I showed you two ways to solve this type of equation. One way was with a shortcut, and another way was using a reciprocal. I'm going to do one of them. I'm going to do each of them with both methods. Okay, so I'll do on this one, on the first one right here, I'll multiply everything by 3. Remember that hack that I told you to get rid of fractions? What's 3 over 1 times 2/3? It's just 2. So this is 2a minus, I have to do 3 times 4. 12 equals 3 times 12, which is 36. That's the way I like to do this problem, is to multiply everything by 3 to get rid of fractions. And then I just finish solving it. Add 12, add 12. 2a equals 48. Divide everything by 2. One of the answers is 24. The other one, I'll do the other way. So I would add 4 to both sides. And I get 2/3 A equals -8. And the other way that I said that we could do this problem is to divide both sides by 2/3, which means on the right side I have to multiply by the reciprocal, because this is -8 divided by 2/3. So it's -8/1 times 3/2. And I do my factoring, and I get that the other answer is -12, -4 times 3. Me personally, out of those two methods, I like this method. But I'll leave that up to you. All right? Two answers, once again, to an absolute value equation. Now, there's something you need to be aware of, though. And it really just boils down to paying attention. If they give you an absolute value equation, and this number that's over here by itself is negative, you can start jumping for joy. It's your easiest problem of the night, because it's no solution. I can't take the absolute value of something and get a negative. It's impossible. This is no solution. No steps, no nothing. You were just intelligent enough to see that they're trying to take the absolute value of something and get a negative. Now they could wrap it in a different package, like this. They could wrap it up and make it look like x plus 5 plus 9 equals 2. This one is also no solution. And you might be thinking, well, why is that? It's equal to a positive 2. Not really. See this plus 9? If I subtract 9 from both sides, this is saying the absolute value of x plus 5 equals -7. This one's also no solution. All right? Now, the first couple problems in your homework are not equations. They are evaluating problems. And so the first couple problems tonight, you're not solving, you're plugging in. If they tell you to evaluate if x equals -2, and they give you something like 23 minus the absolute value of 3 minus 4x, you don't set up two equations because it's not an equation. All right? You just plug in the number. Okay, this is not an equation. All I do is I put the -2 in for x, and I do my order of operations. All right? The first couple problems in your homework assignment are like this. So it's 23 minus the absolute value of 3 minus 4 times -2. Be careful with your order of operations. I need to multiply before I add or subtract. So 4 times -2 is -8. So this is 23 minus the absolute value of 3 minus -8, which is snake eyes. That's 3. This is 3 plus 8, right? So this is 23 minus the absolute value of 11. What's the absolute value of 11? 11. So this is 23 minus 11, which is 12. Okay? The first couple problems of homework are like this. And I think even maybe some of the later ones, anytime they tell you to evaluate, you just plug in the number. The last thing I want to cover is consecutive integer problems. These are some of the problems we skipped over when we were solving. And they're not hard, they just require a special technique that I wanted to give you enough time to learn. I wanted you to become better at solving equations before we tackled this. This isn't hard. It's just knowing how to set them up. So let's do an example here. Let's say they ask us to find, this is nothing more than a solving equations problem. You just got to know how to set it up. If they tell us to find 3 consecutive integers whose sum is -51, the main thing that you have to know is how to set up the equation. How am I going to come up with an algebra expression for 3 consecutive integers? Remember what integers are. They're positive and negative whole numbers. Well, let me give you some wisdom here. I call the first one that I don't know x. The next one, now let's think about counting numbers. What could I add? I'm just going to make up a number, 27. What do I add to 27 to make it turn into 28? Don't I add 1? So the next consecutive integer is x plus 1. And guess what the next one is? X plus 2. And that's your magic formula. Okay? This stands for 3 consecutive integers. Here's the first one, here's the second one, there's the third one. Now look what the sentence says. Find 3 consecutive integers whose sum, doesn't that mean add? Whose sum is, in the algebra world, that's equals -51. And lo and behold, we have an algebra equation that we know how to solve. Now we got to add some like terms, don't we? What's x plus x plus x? Isn't it 3x? So that's 3x plus, combine my 2 and 1 to 3 equals -51. And then I just solve it. Subtract 3, subtract 3. 3x equals -54. Divide both sides by 3. And the first consecutive integer is -18. They told us to find 3. So just count. Now, we need to make sure that we're counting the correct direction on the number line. -18 is the first one. The next one is -17. And then -16. There's my 3 consecutive integers. We used our equation to find the first one, and then we just counted after that. All right? Now, the only other thing that they could really do with this is say, consecutive even or odd integers. That's not a big deal. If they tell you to do consecutive even, I'm not going to do an entire problem. I'm just going to show you how to adjust it. If they tell you to do consecutive even or odd, my first one is x, and my next one is not x plus 1, it's x plus 2. Think about it. Aren't even and odd numbers 2 digits away? Aren't they? 2, 4, 6, 8. Aren't they all 2 digits away? 1, 3, 5, 7. They're all 2 digits away. So you do x, x plus 2, and x plus 4. All right? If it is consecutive, even, or odd. Everything else you just approach the same way. All right? And we're going to stop there for today.